Well, this is sort of anticlimactic because when I start looking at the results, usually I'm sitting there with a cup of coffee at the computer saying, "Ho hum, here we go." And in this particular case, a lot of it was a matter of getting the data organized. Then I usually do what's called a preliminary examination of the data, and the computer spits out a lot of things, and then I just sit down and start looking at it to see how things are going to go from there. So basically, that's where I actually started seeing things fall out, and went back to check the actual data records to see if I had done something incorrectly, because there were some places where things couldn't be calculated. There were, especially the things on the bradycardia, the odds ratios were, for such a small sample size, the odds ratios were quite large. And all of this just sort of, this is not usual. A lot of the things that I get in medical research is there's nothing really going on, and you just sift through the data and you sift through the data and you would like to send back right away. There's nothing going on here. So when at every turn looking at stuff, seeing things where it indicated it to me that either something was going on or I did something terribly wrong someplace along the line. And that's when it really started to dawn on me, and then go a little bit further and look at what was happening, and actually start looking at the individual data records a little bit more carefully as they were sorted out, and that's what I think.
And what did you find out? What was?
Well, to me, the big things were. If we can look at this, I wasn't exactly sure what a lot of this really meant, because of the disorganized, and that was a little bit difficult for me. The thing that really jumped at me was the results here, and as lots of people were saying, well, why didn't you compare C to B and C to D and all of this? In my mind, I did, but the original research was, let's look at B to A, C to A, D to A. That was the objective of the research. Now, I actually looked at these, and just like as another person said, you didn't do these comparisons. Well, actually, the comparisons, comparing A to C, or D to C, or D to B, those comparisons are actually on this chart. They just don't know how to look at it. This is comparing B to A. This is comparing C to A. If you compare this number to that number, you're comparing B to C. And so all you have to do is take the ratio of these two. So if you take this, divide it by that, you're going to get a number of about 3, which is saying that the odds of seeing cardiorespiratory for this group is about 3 times greater than the odds for that group. So all those comparisons are actually here. I just didn't do a statistical test on it because each test, when people do tests, they do each test with a certain level of significance. As you start doing multiple tests, you have to account for all of that kind of stuff. Over here, I accounted for 3 comparisons against this. Over here, each one of these, I was looking at adjusting 3 comparisons for each one of these. There's six possible comparisons that you could do here. I was only interested in 3. The more comparisons you do, the less likely that, the stronger the data has to be to find these differences, and then your sample size has to get very large. A couple of people made comment about the way the study was, and it looked like definitive. These are small numbers. These things here are big differences. And I hate to get a little on the crude side here, but the way statistics works is the bigger the difference, the less information you need to know to find it. It's sort of like trying to determine the difference in heights of midget wrestlers. We call them little people wrestlers these days versus professional basketball players, you don't need to see too many of each to see that there's a difference in their height. You got professional basketball players, though, you got to look at a lot to see the difference in their height, because the differences are minute. You need a lot of information. These differences are massive here. You don't need a whole lot of information to see this. So, but I always, when things turn out like this, I'm always a little bit skeptical that I might have done something wrong. So I actually rechecked this, and I called Barbara and said, "Didn't you guys see any of this going on?" And she said no, which actually was reassuring to me, because it meant that none of the blinding had been broken, and nobody really looked at this. So that's what it was.
So Barbara, tell me the length of the study, how many kids were there, and how long was the data collection done for every baby?
In each group, in Group A we had 11, Group B 11, 11, and 12. It was captured over 2 shifts because we weren't sure if there would be a difference between day shift and night shift, so it was 24 hours, essentially 2 nurses. All nurses had protection of human subjects training, and then we had 1 nurse that just looked for completion of the form. It was the form complete. She didn't even know what the research was about. She was just checking for completion. And we did that because we just didn't want her to have any say in it. And so there's no way that any of us knew what group we were going to be in, or how many of each group that you did, you just really couldn't remember, because we worked 3 12s and then we're off for 4, then you work 3 12s. And so the folders were just in a big big container, and then you just pulled the one from the front, informed consent, went through with the mother, she gave consent, and then you would start your data collection. And so that's why when Dr. Vogel called me and said, "Are you seeing this?" I was like, we can't see it. It's randomized, and we work different shifts, and we're crossing 2 shifts, so we can't possibly see it.